Sound check one. All right, let's go ahead and get started this morning. We're going to talk about solving quadratic equations with factoring, but before we do that, let's go ahead and work a factoring problem. Okay, so when you see a polynomial and you're asked to factor it, let me get this out of the way here. There are two things you need to keep in mind. First of all, you should always look for a GCF. So if you look here at these three terms, and terms are things separated by plus or minus, do they have anything in common that divides evenly into each term? And in this case, they don't. And then the next thing you look at is how many terms you have in order to decide how to approach the factoring problem. Factoring, by the way, just means writing it as a product. And when you have a three-term polynomial like this one, that it often can be written as a product of two binomials. But we need to figure out what these binomials look like. So we're going to have a binomial, two-term polynomial, times a two-term polynomial, another binomial. But we have to figure out what it looks like. Now, before we can get to that point, the method we discussed in class, and there are a variety of methods. There's not one right method, but the one we discussed in class and most methods require that you write the trinomial in descending order of the exponents. So what I mean by that is you would have to write the term 2x squared first, then the term negative x, and then the term negative 6. Okay, and then we used the AC method, and I just want to emphasize that if you want to use a different method, that's fine, but pick a method and stick with it. So this one refers to the fact that this trinomial fits the pattern of ax squared plus bx plus c. So the coefficient of x squared, the number being multiplied by x squared, that is called a. So in this case, a is equal to 2. The coefficient in front of x is called b. And even though it's not written, there is a coefficient in front of the x here. That coefficient, let me just darken this a little bit. Okay, the coefficient of x is actually negative 1. And then the c is always the constant term that doesn't have an x. In this case, c is negative 6. And what we talked about in class was that you multiply a times c, and that would be 2 times negative 1, which, 2 times negative 6, which would be negative 12. And you look for factors of negative 12 that add up to b. So we want factors of negative 12, and their sum has to be negative 1. So thinking about what multiplies to give you 12, we have 1, 12, 2, 6, and 3, 4. All our pairs of numbers multiply to give you positive 12. In order to get a negative 12, you need a positive and a negative. So is there a pair of these where we could do a positive and a negative, and they would add up to negative 1? Well, if you want them to add up to a negative, you use the larger factor as the negative. So we're going to look through here and say, okay, 1 times negative 12 would be negative 12, but 1 plus negative 12 would be negative 11. So we're not going to use that pair. 2 times negative 6 would be negative 12, but 2 plus negative 6 would be negative 4, and that's not what we're looking for. 3 times negative 4 is negative 12. 3 plus negative 4 is negative 1. So this is the pair that multiplies to give us negative 12 and adds up to negative 1. Okay, so now what we do with this in the AC method is we're going to use it to change our trinomial, a 3-term polynomial, into a 4-term polynomial. We practice this in class. The way we do this is we look at this middle term, the x term, and we think about rewriting it as 2 separate terms using the 3 and the negative 4. So the 2x squared and the negative 6, those are going to stay the same. But we're going to split this middle term, negative x, by writing it as negative 4x plus 3x. Recognize that 3 and the negative 4, that's what we just found. So that was the purpose of this procedure over here, was to be able to find 2 terms that, when you add them together, give you that middle term. And then that, if you recall from class, allows us to use grouping, meaning that even though if you look at all the terms, they don't have anything in common to all of them, they do have things in common to pairs. So this first pair of terms, 2x squared minus 4x, that has a 2 and an x in common. So I'm going to write that down. And then we got to think about what's left behind. What's left behind in the first term is an x, because 2x times x is 2x squared. And what's left behind in the second term is a negative 2, because 2x times negative 2 would give us the negative 4x. Plus, then we have the second set of parentheses. What do 3x and negative 6 have in common? What divides evenly into those? And the answer there is a 3. Okay, and so what's left behind? So 3 times what is 3x? Well, that would just be x. 3 times what is negative 6? That would just be negative 2. And what should happen if we've done all of our steps correctly up to this point is you should see that we've created 2 big terms here with a factor of x minus 2 in common. So now we can factor out that x minus 2, and then what's left behind in the first term is 2x, and in the second term is 3. And if you FOILed this out, you would see, FOIL meaning multiply it out, first times first, outer times outer, inner times inner, last times last, you would end up with the trinomial that you started with. All right, so that was factoring. So factoring is really just playing around with an algebraic expression to write it in a different but equivalent form. So why are we interested in doing that? Well, one of the big applications of factoring is to be able to solve equations involving expressions or polynomials that look like the one we had here. So that's what we're going to focus on today. Now, as we're working through the problems, I just want to ask a favor. If you find anything that we're doing helpful, please remember to give this live chat or video, if you're watching the recorded version, a thumbs up. That helps other students to find the video. Okay, so before we look at one that has a problem that has a trinomial in it, let's look at this problem to kind of get an idea of where we're headed. Since we're using Alex, this problem is from Alex, and it says solving an equation written in factored form. So Alex is really good about being very descriptive of what the topic is that we're talking about. So here we have exactly that. We have an equation. You can tell it's an equation, not an expression, because there's an equal sign, right? In the previous problem that we just did, we didn't have an equation. And whenever you're asked to solve, people throw that word solve around kind of loosely, but there's a very specific meaning for it. When you solve an equation, you're looking for a value, a number, for the variable that makes the equation true. So sometimes when I'm working with students and they see a problem like this one up here, a factor or other types of problems, they say, oh, we have to solve it. We're not solving because we're not looking for a number that makes an equation true. In fact, we didn't even start with an equation. The equal sign we put in here was to show that what we started with on the left is the same as what we got on the right, but that's not the same as when you start out with an equal sign and you're trying to figure out a number that makes this algebraic statement true. Anyway, we're not going to solve this equation the way we do linear equations, where there aren't two factors being multiplied. We're going to have to use a little bit of logic, which I actually kind of like about these problems, that you have to use reasoning, not just steps, adding and subtracting. But you have to think to yourself, we have two mystery numbers, right? We have the number 3y plus 4, which is an unknown. And then we have the number 6 plus y, another unknown. These two unknown numbers are being multiplied, and the result is 0. So we know from experience that the only way you can multiply two mystery numbers together and get 0 is if one of them happened to be 0. So what we can conclude is that the only way that can happen is if either 3y plus 4 were 0 or 6 plus y were equal to 0. And so anytime you have a product of two unknowns equal to the number 0, you can break it apart and we get two simpler equations to solve. Now let's go ahead and solve. All right, so on the left, 3y plus 4 equals 0. We would subtract 4 from both sides of the equation. When I say both sides, by the way, I'm talking about both sides of the equal sign. So subtracting 4 on both sides, we get 3y equals negative 4. And then now we would observe that 3 is being multiplied by y. That's the operation that's going on here. So to reverse that operation, we need to divide by 3 to get y completely by itself. But whatever we do to one side of the equation, we must do to the other. And so we would have y, or 1y, but you don't have to write the 1, equals negative 4/3. Or, and then here we have on the other side, 6 plus y equals 0. So I'm going to subtract 6 from both sides to get y by itself. We get y equals negative 6. All right, so our solution set contains both negative 4/3 and negative 6. Okay, so that's solving an equation written in factored form. But let's try finding the roots of a quadratic equation with a leading coefficient of 1. What the heck does that mean? Okay, so that's the next topic. It has a lot of vocabulary that we need to pay attention to. So roots of an equation are solutions. That's it. We're just solving the equation. We often use the term roots instead of solutions when we have an equation that we're solving by putting a 0 on one side. But just think of the roots as the solutions to the equation. Okay, what is a leading coefficient of 1? Well, when you have a polynomial and it's written in descending order of the exponents, which this one is, we have a squared x, we have an x to the first power, and then we have no x. Then the leading coefficient is referring to the number that's being multiplied by the highest degree term, the x squared. And since there's nothing written, there's a 1, it's just not visible. So the coefficient, leading coefficient is a 1, is what they're saying here. And then what does it mean to be a quadratic equation? A quadratic equation is any equation of the form a times x squared plus b times x plus c equals 0. It might not start out in that form, but if you can rearrange it to get it into that form, then it's considered a quadratic equation. The key element of a quadratic equation is this, the squared power. So the a cannot be 0. This term has to be visible. In this case, a is 1, but it could be any number. It's just that when a is 1, there are some differences in how we are able to solve the equation. So we're going to focus on those types first, and then we'll go on and see what happens when a is not 1. But you see here that we have a is 1, b is -6, and c is -7 in this quadratic equation. All right. Now the technique that we're going to use, and there's more than one technique, of course, lots of tools we can use to do mathematics. The one that we're going to use is we're going to use this idea that if we could transform this equation so that it looked like a product of two mystery numbers equal to 0, then we could set each of those mystery numbers equal to 0 and solve for the variable to find out what it could be, what the solutions could be. So in other words, we're going to factor. It's important that you notice that we already have 0 on one side. That's an important requirement. If there's not a 0 on one side, this factoring idea will not work until you get 0 on one side. When there is 0 on one side, by the way, to throw yet another vocabulary word at you here, this is called the standard form. Standard form just means that you have it where it matches up with ax squared plus bx plus c equals 0. Okay, you have a 0 on one side. All right, so that's a lot of vocabulary. Solutions are the roots. Quadratic equation is any one that looks like ax squared plus bx plus c equals 0 if you rearrange it. And in this case, we're looking at one that in particular has a leading coefficient of 1 in the front of the x squared. All right, the method that we're going to use again is the AC method. So we have to identify A is 1, B is -6, and C is -7. We're going to look for factors of the product AC that add up to B. So notice that A times C is equal to 1 times -6, 1 times -7 is -7, and B is -6. So we're looking for factors of -7 that add up to -6. Now when I say factors, all I'm talking about are things that multiply to give you that number. There's only one pair of numbers that multiplies to give you 7. That's 1 and 7. We want them to multiply to give us a negative, so one of them needs to be negative. And which one needs to be negative if we want them to add up to a negative as well? That would have to be the larger, -7. So 1 times -7 is -7, and 1 plus -7 is -6. So this is the pair of numbers that we're going to use to split the middle term. Now, if you notice that there's a shortcut besides splitting the middle term, just be patient. I'll get to that in a minute. Okay, so what we're going to do is keep the x squared term the same, the -7 the same, the 0 the same, but what we're going to do is we're going to replace this -6x here with the sum of the two terms with coefficients 1 and -7. So I'm going to write this as -7x plus 1x minus 7. Okay. Now remember, the reason we did that is so that we could turn a 3-term polynomial, a trinomial, into a 4-term polynomial and use grouping. So let's go ahead and use some grouping here. So I'm going to put parentheses, okay, around there. And then what do the first pair of terms have in common? They have an x in common, and what's left behind is x minus 7. Plus the second pair of terms, the only thing they have in common is a 1, but once again it leaves behind an x minus 7 when you factor out that 1. So we've created two giant terms separated by that plus. Don't be misled by these parentheses. Sometimes people think we've already factored the problem, but we're not done because factored forms have only multiplication outside the parentheses. This plus in the middle is indicating that we have not yet completed the factoring process. So what do we do next? We are going to factor out the x minus 7, and let's just notice what's left behind in each term. The x and the 1 are going to be left behind. So we have x minus 7 times x plus 1 equals 0. There's that x and that 1 that were left behind. We've factored out from there. Okay, and now we have two mystery numbers again that have a product that multiplies to give you 0. So the only way that can happen, that you multiply two numbers together and get 0, is if one of them is 0. So either x minus 7 is 0 or x plus 1 is 0. So if x minus 7 is 0, adding 7 over to the right, we get x is 7. If x plus 1 is 0, we can subtract 1 to get negative 1. So the solutions to this are x equals 7 or negative 1. Okay, oops. We do not want to use a parenthesis here. Parentheses are reserved for intervals or ordered pairs. Whenever you're giving a list of solutions to an equation, you should use curly brackets. Okay, so I said there's a shortcut. Because the leading coefficient of this particular problem was a 1, you might or might not have noticed that this number, this pair of numbers that we got, 1 and negative 7, were the numbers that we used to factor down here. There is a shortcut that says that if a equals 1, if the leading coefficient is 1, then you can skip the grouping and go directly to the factored form. This only works when a is 1. But it saves you a lot of time. Now, if you don't notice, if you don't remember, and you do the split the middle term and do the grouping, you're still going to get the right answer in the end. But if you do notice, you can just skip directly to this factored form and set each factor to 0 and solve for x, and that's all you have to do. So that's a nice little shortcut for that type of a problem. Okay. All right. Anybody watching this live has the option of asking questions in the chat bar. So, all right, the next type of problem we're going to look at, notice that it's an equation. Again, we're solving an equation. And again, Alex is very descriptive about the topics. So this topic is finding the roots of a quadratic equation of the form ax squared plus bx equals 0. Notice that the equation they're giving us, first of all, the variable is not an x. That doesn't matter. It's going to work the same no matter what the variable is. But also, it's not currently in a form with a 0 on one side. The standard form of 0 on one side is necessary to use factoring to solve the equation. So whenever that's the case, you're going to take your equation, v squared equals 13v, and we're going to get 0 on one side by just subtracting all the terms from one side of the equal sign over to the other side. So we're going to have v squared minus 13v equals 0. That fits the pattern that they're talking about here. Now, a lot of times people recognize that, yes, we have a quadratic equation because we have a power of 2. But they don't know what to do about the fact that there's no third term here. It doesn't look like a trinomial, it looks like a binomial. In fact, this actually makes the problem easier in this case because remember, whenever you go to factor, the first thing you should look for is to see if you have a GCF and then worry about the number of terms. So do we have a GCF, a greatest common factor for v squared and negative 13v? In this case we do, right? Just v. So you can factor the v out, leaving behind in the first term a v and in the second term a negative 13. And then we have equals 0. And now look, we have two mystery numbers again. So we have the mystery number v and the mystery number v minus 13. And when we multiply them together, we get 0. So using logic and reasoning, we could conclude one of them has to be 0, right? So either v is 0 or v minus 13 is 0. One or the other has to be true. So this is going to give us the only possible values of v that would make the statement true. In other words, the solutions. Either v is 0, that one's already solved, or adding 13 to both sides of the equal sign, we would have v is equal to 13. All right, so there are two solutions in our solution set, 0 and 13. And remember, do not put parentheses because if you put parentheses, that would indicate an ordered pair, an xy, or an interval. And we don't have an interval. We have two distinct values, 0 and 13. Both of which, if you notice, if you plug them into the original equation, it would make the statement true. Good morning, folks. If you're just joining, remember to type in your name or alias and the days and times of your class. And you can get bonus points. And if you're watching later the recorded version, you can still type in a comment, but you should include a quotation from the video. All right, so we were just talking about how to use factoring to solve an equation. And we're going to do a few more examples here. These are called quadratic equations because the polynomials have a power of 2. All right, so here's another example from Alex. It says solving a quadratic equation needing simplification. So remember, the standard form of a quadratic equation looks like ax squared plus bx plus c equals 0. Basically, think standard form, you have 0 on one side. So if you look at the equation we're solving here, we don't have that. There is no 0 on one side. Also, we have this quantity being squared, which you definitely don't see in the standard form, anything like that. We want separate terms. So we have some rearranging to do to get it to match up with what we consider the standard form before we can try to use factoring. So let's go ahead and first of all, we're going to square the x plus 6. Okay, now squaring a binomial is something that happens a lot and it's a common source of error. And that's in every class I teach, from intermediate algebra all the way up through calculus 3. I see people make an error with squaring a binomial. The thing is that when we have something like 5x, say, this is a different problem. This has nothing to do with the problem we're working now. If you square 5x because it's a product, that's the same as saying 5x times 5x. And you can rearrange that. That's 5 times x times 5 times x. Same as 5 times 5 times x times x. So it's the same as 5 squared times x squared, or 25x squared. Of course, we don't do all that work. We just say, oh, 5x squared is 25 times x squared. But that's because it's multiplication. Inside the parentheses that are being squared, you can just square each part and it works out nicely. Not the case when we have a binomial like x plus 6. So to square x plus 6, a lot of times people want to just say x squared plus 36, but that's incorrect. Because remember, x plus 6 squared is the same as x plus 6 times x plus 6. And in order to multiply that out, you have to FOIL. So you would do first times first is x squared. Outer times outer would be 6x. Inner times inner would also be 6x. And last times last would be 36. And then the two terms in the middle actually turn out to be like terms, so this turns out to be x squared plus 12x plus 36. Now, there is a shortcut to get from x plus 6 squared directly down to this guy here. And there's a nice little rhyme you can remember to help you get there. So the rhyme goes like this: square the first. And by first, we mean the first term. So the first term is the x. So that gives you x squared. And then it says square the last. And by last term, they're talking about the 6 here. So 6 squared, or 36. And then you say multiply together and double up fast. So multiply together is referring to multiplying the 6 times the x. And double up fast is saying to double this guy, so that'd be 12x. So what we have is our x squared, our 36, and our 12x that we got right here. Okay? All right. So as we work through different problems, I'm going to remind you of that little rhyme because it's important to start recognizing this pattern: the first term squared, the last term squared, and twice their product in the middle. All right, so on the left then, I'm going to write x squared plus 12x plus 36. And then on the right, I have 2x squared plus 17x plus 22. And now I want to get this in standard form, so I want 0 on one side. It really doesn't matter if you have ax squared plus bx plus c equals 0 or 0 equals ax squared plus bx plus c. The 0 can be on either side. The way I like to do it is whatever, move the x squareds to whichever side will leave the coefficient positive. So in this case, I would rather, for example, subtract the x squared rather than subtracting 2x squared. Okay, but if I subtract the x squared, I'm going to subtract also the 12x and the 36. I want to get everything over to one side. All right, so we're going to have 0 equals, and then we're going to have x squared plus 5x, and then minus 14. Okay, so now we have standard form because we have 0 on one side and we have the descending order of the exponents. The x squared comes before the x, which comes before the term with no x. So it fits the pattern of ax squared plus bx plus c, where a in this case is 1, b is 5, and c is negative 14. All right, now the reason that's important is because we're going to factor, and this is a nice form for us to be able to factor in. We are going to use the AC method, or whichever method you prefer. A times c in this case would be negative 14, and b is 5. So we're looking for factors of negative 14 that sum up to 5. Anybody who's watching, can you think of two factors, two numbers that multiply to give you negative 14 but add up to a positive 5? Let me give you a minute to think about that. There's a little bit of a delay between when I speak and when you hear me, so we have to be patient with interacting. But if you could type into the chat bar two numbers that multiply to give us negative 14 and add up to 5. Who's going to be brave? By the way, if you haven't typed your name or alias and the day and time of your class into the chat bar, please do that so you can get bonus points. Debonique or Alani, anybody gonna tell me what factors multiply to give you negative 14 and add up to 5? Very good. Thank you, Debonique. All right. So we have 7 and negative 2. So what are we going to do with that 7 and negative 2? Well, normally I would say split the middle term and create a 4-term polynomial. But remember, this was the special case where a is equal to 1. So we have a shortcut. We can literally just say that 0 has to be equal to, I didn't write down my 7 and negative 1 here. So we're going to use the factors the numbers 7 and negative 1. So that means this factors into x plus 7 times x minus 1. Oh, negative 2, not negative 1. I'm sorry. Right, because 7 times negative 2 gives you the negative 14, that's the C term, and 7 plus negative 2 gives you the 5, that's the middle term. Okay, so why is this a helpful form to have it in? A factored form equal to 0, because again, we have two mystery numbers being multiplied to give you 0. The only way that can happen is if one of them is equal to 0. So either x plus 7 is equal to 0, or x minus 2 is equal to 0. If x plus 7 is equal to 0, then x is negative 7. If x minus 2 is equal to 0, then x is 2. So our solution set includes negative 7 and 2. Okay. Don't be afraid to let me know if you have any questions about this or anything else. Just type it into the chat bar. But in the meantime, I'm gonna keep moving along. All right, so now we have another example from Alex, which says finding the roots of a quadratic equation with leading coefficient greater than 1. All right, so that means that you can't use the shortcut of not splitting the middle term, but that's okay. We know how to do the work. All right, so what do we have to do first before we can start factoring? So remember, on the test, it's not going to say necessarily solve this quadratic equation by using factoring. You have to be able to, first of all, identify that you have a quadratic equation because it has a squared term. And you have to remember that when you have a quadratic equation that you want to get it in standard form. And the most important thing to remember about standard form is equals 0 on one side. So let's go ahead, and since there's already a positive coefficient of x squared on the left and no other x squareds, let's just keep it moving everything to the left. So thinking of the equal sign as like a wall, we're going to add 30x and 25 to both sides to keep the balance. All right, so we're going to get 9x squared plus 30x plus 25 is equal to 0. All right, so now we need to use the AC method, or whatever method you're comfortable with. But again, I only have time to use one method, so we're going to stick with the AC method. So now we have it in standard form. ax squared plus bx plus c equals 0. Everything matches up. So we have a is 9, and b is 30, and c is 25. So if we use the AC method, we multiply 9 times 25, which is going to give us 225. And then we're looking for factors of 225 that add up to b, and b is 30. So we want factors of 225 that add up to 30, that sum to give us 30. So when you have large numbers like this, don't panic. All right, just because you can't look at it and instantly know what two factors of 225 add up to 30, don't worry. You can actually just start writing down pairs of factors, and it'll go very quickly, even though it's a large number. So what I mean by that is you ask yourself, what goes into 225? So 1 goes into 225 225 times. 2 doesn't go in because it's not an even number. 3. Does 3 go into 225? Well, it goes into 22 7 times with 1 left over. It goes into 15 5. So yeah, 3 and 75. Neither of these pairs so far adds up to 30, so we're going to keep going. 4 is an even number, so that won't work. How about 5? So how many times does 5 go into 225? So 5 goes into 225 45 times. That adds up to 50. Well, the sum is getting smaller. Notice we went from a sum of 226 to a sum of 78 to a sum now of 50. So we're getting there. Okay, does 7 go into 225? No, not evenly. Does 9 go into 225? I think it does. 9 goes into 22. Let's see. It goes into 18 evenly, so it goes in twice, leaving 45. So 9 times, oh, of course, 9 times 25. We had that product there. And then 10 doesn't because it's even. 11 doesn't go in evenly. 13 doesn't go in evenly. Let's see. Let's try 15. So how many times does 15 go into 225? It goes in, let's see, 15 times. Okay, and 15 plus 15 does add up to 30. So we can use this pair to split the middle term. So we have 9x squared, and instead of 30x, we're going to write plus 15x plus 15x plus 25 equals 0. And now we've turned a 3-term polynomial into a 4-term polynomial, and we can use grouping. What do the first pair have in common? We have a factor of 3 that goes into both 9 and 15, and then also a factor of x. So what's left behind in the first term? Well, you would have to multiply 3x by 3x to get 9x squared. And in the second term, what would you multiply 3x by to get 15x? That would be a 5. Plus, over here, we have a 5 in common, leaving 3x plus 5. So notice that we have two big terms with a 3x plus 5 in common, and what's left behind is a 3x and a 5. So factoring out 3x plus 5, we have 3x plus 5 left behind, which is interesting. All right, so we could write this factorization as 3x plus 5 quantity squared, by the way. But either way, we have a single mystery number that when we multiply it by itself gives us 0. So that number must be 0. 3x plus 5 must be equal to 0, which would mean 3x is negative 5, subtracting 5 from both sides of the equal sign. And then dividing by 3, we get x equals negative 5/3. So in this case, there is only one number in the solution set. With quadratic equations, you can get no solution, you can get one solution, or you can get two solutions. Okay. All right. Again, don't be shy about typing a question into the chat bar. All right. Now, even though the coefficient of this particular equation, a, was not 1, so we couldn't use the shortcut of just jumping to the end, we had to split the middle term. There is another alternative for a little bit of a shortcut. And that alternative involves perfect square trinomials. So when you notice that the number that you start with for the coefficient of x is of x squared rather is a perfect square, and the number at the end is also a perfect square. So 9 is 3 squared and 25 is 5 squared. Then you might want to check before going through the grouping process. You might want to check if you have what's called a perfect square trinomial. In fact, we do here. And what I mean by that is, so just notice, what you can do is when you see that 9 is equal to 3 squared and you see that 25 is equal to 5 squared, then what you can do is you can say, well, is it possible that this trinomial is equal to 3x plus 5 squared? Now, it's not guaranteed to be. It depends on if this middle term is appropriate. But remember that little rhyme we talked about for squaring a binomial? You square the first, which would give you the 9x squared. You square the last, which gives you a 25. You multiply together, which would give you 15x, and you double up fast, which gives you 30x. When you do that, when you multiply this out, you see, oh yeah, that is the same trinomial that I have there. So that allows you to just skip to the end and say, oh, so 3x plus 5 squared is equal to 0, and then set that equal to 0 and solve for x. So this only works if you notice that you happen to have the a and the c are perfect squares. Right? If you prefer, you can stick with the AC method, or if you don't notice that they're perfect squares, it's not going to hurt anything for you to do the AC method. But the nice thing about that is a lot of times these perfect square problems have very large numbers for you to factor. So if you notice it's a perfect square problem, you might be able to avoid having to make that list. Okay. All right, now we're going to look at a slightly different topic. This is going to be the last exercise we do today. The topic is word problems involving perimeter and area. Some of these word problems result in linear equations and some of them result in quadratic equations. It just depends on the information that's given. So let's look at this one. The length of a rectangle is 3 times its width. If the perimeter of the rectangle is 56 feet, find its area. So whenever you see a word problem where you have a reference to a shape, draw a picture. Can never hurt to have a diagram in front of you to help you think through the information. All right, so we have a rectangle. And actually, I can make a nicer rectangle. I forgot. We have some nice rectangle options here. There we go. There's a nice rectangle. Okay, so the length of the rectangle is 3 times its width. So they're not telling us the width, but they are telling us something about the length in terms of the width. So let's go ahead and let the width BW, then the length is 3 times W. So I'm going to label this the dimensions W and 3W. And in fact, I'm going to label all 4 sides just to be clear. Okay. All right. So here's our rectangle. W is the width, 3W is the length. It says that the perimeter of the rectangle is 56 feet. Remember, perimeter is just the sum of the lengths of all the sides. So to say that the perimeter equals 56 means that if we added up all 4 of these sides, we get 56. So W plus 3W plus W plus 3W equals 56. Which would mean, if we combine like terms, that 8 times W equals 56. All right, so we're going to divide both sides by 8 to get the width by itself. So W, the width, is equal to 7. Now, since we're talking about dimensions of a shape, we're going to look for the units. So the width is a linear unit. It's a length. And if you look here, we're talking about the perimeter being measured in feet. So if you walked around the outside, the perimeter is 56 feet. So the width is actually 7 feet. Okay. Now, did they ask us, should I type into Alex the answer 7? Well, no, they're asking us to find the area. And what we have just found is the width, not the area. So how do we find area when we are working with a rectangle? The area of a rectangle is the length times the width. So we have half the information that we need. The width is 7. How can we find the length? Well, we know the length is 3W. So 3W, if W is 7, 3W is 21 feet. So to find the area, we're going to need to multiply 21 feet times 7 feet. 21 times 7 is 147. Feet times feet is feet squared. Area is always measured in square units. So our solution would be 147 square feet. Okay, so that's all that we're going to do today. Please remember to keep following along in your syllabus. By the way, if you found the video helpful, please give it a thumbs up. That will help other students to find the video. And you can always subscribe to my channel so that you'll get notifications when a live chat is starting. Just keep in mind that sometimes it's live chats for other classes. Okay, I hope you guys have a good weekend. Remember, you can always send me your questions via email. The fastest way to get in touch with me is either qhearn@broward.edu or using your Skype option that's given in the syllabus. All right, guys, have a good weekend, and thank you for tuning in.